All right, in this section, we are going to learn how to solve equations that are quadratic in form. And so let's just go ahead and start with an example. So if I have 3x to the fourth minus 2x squared minus 1 equals 0. So what I'm going to do here is notice the reason that it's called quadratic in form is because notice that we do have higher power values of x, and it's something that we can solve using a quadratic function, because what I'm going to do here is I'm going to do what's called u substitution, and I'm going to let u equal to x squared. Now notice on this one that the second term, the middle term, the variable is x squared. So I'm going to always go off of this middle term. Now if u is x squared, then u squared would be x to the fourth. So notice what I have is, if I substitute the u's in for the x's, x to the fourth would be u squared minus 2, and then x squared is u. And so I can make this into a quadratic function, or a quadratic equation. All right, so now I'm just going to go ahead and factor it. So remember, this is one that the leading coefficient is not 1, so it's a harder kind of factoring. So I'm going to go 3 times negative 1, negative 3, which gives me negative 1 times 3, and that's the only thing that I can use, which gives me 2, but I want negative 2, so right numbers but wrong signs. So this would be 3u squared. I'm going to split this up into plus 1u and minus 3u, and then bring down the negative 1. So now I have 4 terms, so I factor by grouping. So here I have a u in common, so factor it out, and if I divide this by u, I get 3u plus 1. So u into u squared gives me u, and then here the two u's cancel, so it's just equal to 1. And then here I don't have anything in common except for the negative, so I'm going to take out a negative 1. So this is going to be, if I divide by negative 1, I would get negative and a negative is positive, and then negative and negative is equal to positive. All right? So now I have 2 terms, and both terms have 3u plus 1. All right? So now I can either do it here or, well, actually, let me go ahead and set them each equal to 0. So I can either use the substitution here, or I can resubstitute later. I'll go ahead and resubstitute now. So, and in the next problem I'll resubstitute later, just so you can see you can do it either way. All right, so on this one, I'm going to let u was x squared, and so I'm going to now resubstitute what u is equal to, which is x squared. All right, and so that's going to subtract the 1 and then divide by 3. And then take the square root of both sides, plus or minus. You get x is equal to plus or minus the square root of 1/3 I. And then on this one, I have u minus 1 equals 0. And I'm sorry, not u, but I'm going to make it x squared. So resubstitute on this one. And I get x squared equals 1. Take the square root of both sides. Don't forget plus or minus. So I get x is equal to plus or minus 1. All right. So again, I started with x to the fourth. So remember, I should get 4 answers, and I do. I get plus 1 square root of 1/3 I minus square root of 1/3 I plus 1 and minus 1. Okay, problem number 2 says x to the 4th minus 8x squared minus 9 equals 0. So again, looking at my middle term, I'm going to let u equal x squared, just like I did in the previous problem. Because this middle term, the variable in the middle term, is what gives me what u is. And so then u squared is equal to x to the 4th. So this would be u squared, x to the 4th is u squared, minus 8, x squared is u, minus 9 equals 0. So then I'm going to look at negative 9. This is an easier factoring. So this would be negative 1 and 9, or negative 3 and 3. I'm looking for 8. So the negative 1 and 9 gives me 8. But I want negative 8, so right number but wrong sign, so change both of the signs. So I get u plus 1 times u minus 9 equals 0. All right, so here u plus 1 equals 0, or u minus 9 equals 0. So again, resubstituting, u is equal to x squared, so this becomes x squared plus 1 equals 0. Subtract the 1, and then take the square root of both sides. Don't forget plus or minus. Get x is equal to plus or minus I. And then here, x squared minus 9 equals 0. So x squared equals 9. Square root of both sides, plus or minus. X is equal to plus or minus 3. So that's how you use u substitution to make it into a quadratic equation so that you can factor it, and then you have to resubstitute. Now there are some other problems that are very similar to these that we can work in a very similar manner using the u substitution. So problem number 3 says x plus 2 squared plus 11 times x plus 2 minus 12 equals 0. So notice that my middle term, my variable here, includes a constant because it's in parentheses with the x. So I'm going to let u equal x plus 2. All right? So this gives me, so of course u squared would just be x plus 2 squared. So this is going to be u squared plus 11u minus 12 equals 0. So now factoring this, I have negative 12, which gives me negative 1 times 12, negative 2 times 6, negative 3 times 4. So I'm looking for 11, and negative 1 times 12, or negative 1 plus 12 gives me 11. So that's the numbers that I want. So this is going to be u minus 1 times u plus 12 equals 0. So here u minus 1 equals 0, or u plus 12 equals 0. Resubstituting, x plus 2 minus 1 equals 0. So just wherever I see a u, I'm going to plug in x plus 2. So now combining like terms, I get x plus 1 equals 0. So x is equal to negative 1. On this one, I have x plus 2 plus 12 equals 0. And so this would be x plus 14 equals 0. So x is equal to, subtracting the 14, negative 14. Okay. Problem number 4 says x minus 5 squared minus 4 times x minus 5 minus 21 equals 0. So in this one, if I look at this middle term, my middle term is x minus, my variable here is x minus 5. So I'm going to let u equal x minus 5. So this would be u squared minus 4u minus 21 equals 0. So now looking at negative 21, it will factor into negative 1 times 21, or negative 3 times 7. So the 3 and the 7 give me 4. I want negative 4, and so that means right numbers but wrong sign, so this changes to plus 3 and minus 7. So I have u plus 3 times u minus 7 equals 0. So that would give me u plus 3 equals 0, or u minus 7 equals 0. So now resubstituting, x minus 5 plus 3 equals 0. Combining my like terms, I get x minus 2 equals 0. So then add the 2 to both sides, I get x equals 2. On this one, I have x minus 5 minus 7 equals 0. So combining my like terms, I get x minus 12 equals 0. Add the 12 to both sides, and I get x is equal to 12. All right, problem number 5. X plus 4 squared plus x plus 4 minus 6 equals 0. So here I'm going to let u equal whatever's in the parentheses with the x plus 4. So this would be u squared plus u minus 6 equals 0. And I just refactor that just like I always factor. So I look at negative 6, and that can either be negative 1 times 5 or negative 2 times 3. The 2 and the 3 give me 1, which is what I'm looking for because my coefficient here is understood to be 1. And it should be positive 1, and that's what I get here. So this will factor into u minus 2 times u plus 3. So I have u minus 2 equals 0, or u plus 3 equals 0, and then I resubstitute. So that would give me x plus 4 minus 2 equals 0. So x plus 2, combining my like terms, 4 minus 2 is 2, and then subtract the 2 from both sides, and I get x is equal to negative 2. Over here, resubstituting, I get x plus 4 plus 3 equals 0. So combining my like terms, 3 plus 4 is 7. So I have x plus 7 equals 0. Then subtract the 7, and I get x is equal to negative 7. Problem number 6. X to the 4th minus 9x squared plus 20 equals 0. All right, so on this one, notice again my middle term, it's x squared, so I'm going to let u equal x squared. And so u squared would be equal to x to the 4th. So x to the 4th is u squared minus 9u plus 20 equals 0. And then that will factor into, well, let's look at the 20. And it's going to be either 1 times 20, 2 times 10, 3 won't go into it, but 4 will, and 4 times 5. Well, the 4 and 5 give me 9, but I want negative 9. So that means right numbers but wrong signs, so change both of them to negative. All right? So now this is going to give me u minus 4 times u minus 5 equals 0. So if I have, so plugging in, now resubstitute, excuse me, let me go ahead and set each equal to 0. U minus 4 equals 0, or u minus 5 equals 0. And you can substitute here if you want, and you can solve for u and substitute there if you want. All right, so this is going to be x squared minus 4 equals 0. So bring the 4 over, and I could either factor this again, but I always do this using the square root method because on some of them you can't factor. So this is going to be x squared, add 4 to both sides, and then square root, and don't forget plus or minus. So I get x is equal to plus or minus 2. And then this one, resubstituting, I get x squared minus 5 equals 0. Bring the 5 over, and then take the square root of both sides. Don't forget plus or minus. So x is equal to plus or minus the square root of 5. So on these, just to kind of recap, when you have one that either has x to the fourth, or if you have this in parentheses, what you're going to do is you're going to use u substitution, and you're always keying off of this middle term. All right, so here we use u as x squared, here we use u as x squared, here we use u as x squared. Here we use u is equal to x plus 2, here u was x minus 5, and here u was x plus 4. All right, now, what I've seen a lot of students, this is just a hint, what I've seen a lot of students do before is go ahead and FOIL this out, multiply this by 11, and then combine your like terms. And you can work the problem that way, and you will still get the same answers of -1 and -14. However, it does take a lot longer to do all that foiling out and combining like terms and then doing the factoring. So I would recommend that you do these in this way. All right, so that is how you solve equations that have a quadratic form.